Alright, we're back with another algorithm video. In this video, the problem is, given two non-empty sorted arrays, devise a way to find the median of both without having to merge the two together. So our first indication would be to look at these two arrays and put them together in a sorted manner, and then go one from the left, one from the right, and keep doing that until we have one or two in the middle. Unfortunately, this problem specifies that we can't do that. We have to do this without merging. But fortunately, doing it this way will give us a more efficient time complexity. Alright, so here is the actual algorithm we have. This is the pseudocode for it. I'm going to go ahead and explain the pseudocode through an example because that's the easiest way to understand it. Alright, so we're going to have a few variables that we pass to the function. And before we start, I should mention that this is going to be a recursive function. So if a certain condition is not met, we'll be looping up to the condition, to the function itself with different conditions, with different parameters. Alright, let's start with the example. We're given the two arrays, A and B, this and this, and notice how we've set the A as the smaller one. That's important. This could be flipped around and the smaller one could be B, but then in our main function we would have to specify that we would have to switch that. Alright, so we want A to be the smaller one. Alright, next on our first iteration, since this is the first iteration, we're going to set min as 0 and max as the size of A minus 1. Size of A is 4, and then minus 1 is 3. So max is 3. And then for the size A and size B, those are just the sizes. So B is 6 and A is 4. Just like that. Now that we have our parameters that are being passed into the function here, we can actually start doing some arithmetic. So we're going to be finding the middle points of the arrays. Basically what we're going to be, I keep saying basically, but what we're going to be doing is splitting these two arrays down the middle and trying to make it so that the left of B plus the left of right has the same amount of indices as the right of B and the right of A. And we're going to do that through some simple arithmetic. So we're going to find the middle point of A through the minimum plus the maximum divided by 2. So the mid of A is 0 plus 3 divided by 2, which is 1.5, but since we're working with integers, that would be rounded down to 1. So mid of A is 1. Alright, and then we can calculate mid of B because mid of B is dependent on what mid of A is. Alright, so let's do that. Mid of B is B length plus A length plus 1. So that would be 4 plus 6 plus 1 is 11 divided by 2 is 5.5. Round that down to 5 and then subtract whatever mid A is. So that would be 5 minus 1 is 4. Just like that. And then we're going to find these A left, A right, B left, and B right. And how we're going to do that, let me show you through a visual here what we're doing. So we found the middle point of A, and that's going to be to the left of index 1. So we go to array 1 here, or array A, excuse me, and we go to index 1, 0, 1, and we put the split to the left of that. Just like that. And then we do the same for the B array. So we go to 4, 0, 1, 2, 3, 4, and then put the split to the left. So now you can see we have the same amount of indices on the left as the right. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And that's because we have an even amount of indices all together. We have 1, 2, 3, 4, and then 6 is 10. If we had an odd amount, we would simply have one extra on the left-hand side. Alright, and that's what this arithmetic over here is, or here, is doing for us. It's making sure that we have the same on the left as on the right. Now we can set our lefts and rights of each array. So here, visually, we can just look and see the left of array A is 2, and then the right is 3. We're looking at the left and right of the split. Alright, so we'll write those in, 2 and 3. And then we do the same thing for the left, or the B array. So we do 8 and 12. And then for the actual program, we'll just be doing the a left is equal to the index mid minus 1, and then mid. Alright, moving on to step B, we're going to check if all the integers on the left are less than those on the right. And if so, then we found the 4 integers that are in the very middle if we were to combine these two arrays. Alright, so we're going to check if a left is less than b right, because we already know that the a left is less than b right, or a right, because they're in the same array and that array is sorted. So now we have to check if the left of a is less than the right of b. Alright, and it is, and then we do the same thing for b and a. So 8 is not less than or equal to 3, so we have to do something else. So what we're going to do is we're basically going to, I say basically a lot, I know, we're going to move this split over 1 and this split right here to the left 1. And what that'll do, that'll give us bigger numbers for A and smaller numbers for B. And we're trying to find that sweet spot where those 4 numbers are if we were to combine this. Alright, so what we're going to do is, since the B left is not less than the A right, we're going to execute this condition down here. We're going to basically recursively call the same function, but the only difference is we're going to do the start index as mid A plus 1. So we're just shifting this line over 1. And let's do the whole thing just so we can see. So the min is set to 1 now, and the max is still 3, size is still 4 and 6, and the arrays are still the same. Alright, let's calculate the middles. So mid A is 3 plus 4, or sorry, 1 plus 3 divided by 2, so that's 2. As you can see, 2 is 1 more than 1, so we just incremented. And then mid B is the lengths plus 1, so 11, 5.5 rounded down to 5 divided by, or sorry, that would be minus the mid A. So 5 minus 2 is now 3. Alright, so that just got incremented downwards. And that's what we want, because we just want to go one by one, checking if we're at the sweet spot. Now we're going to set all 4 of these variables. So let's first off change where our splits are. So our split for array A is at the left of 2, so 0, 1, 2 to the left of 5. And then the split is to the left of index 3, 0, 1, 2, 3. You can see they just got shifted one place. Alright, now we won't do the arithmetic, we'll just look. So 3 and 5 for A, you can see that 3 is on the left, 5 is on the right. And then same thing for B, that would be 5 and 8. Now we do our step B and check if A left is less than B right and B left is less than or equal to A right. It's really less than or equal to, but I just say less than a lot. So 3 is less than or equal to 8, so that's good, and 5 is less than or equal to 5. So we found the sweet spot. We can do stuff with these numbers now. Alright, so combined, if we were to combine these arrays, basically the middle would look something like this: 3, 5, 5, and 8. And then our split would be there. So what we're going to do with these 4 numbers now that we found them is we're first off going to check if we have 2 or 1 numbers in the middle. Basically if we have an odd number of integers altogether or even. And that's what we're doing right here in these steps. Alright, so we have 4 and 6 equals 10, mod 2 is 0, so we have an even number of indices. And if you wanted to check, you could just count how many numbers there are. So we have an even, so we're going to return whatever's maximum on the left hand side and minimum of the right hand side. So here's our left, we're going to return the maximum, which is 5, plus the minimum of our right, which is 5, divided by 2. So 5 plus 5 is 10, divided by 2 is 5. And as you can see, we have 5 in the middle, and then 5 in the middle, and then we add and divide, and that gives us 5. Alright, that's how this algorithm works. We're going to implement the pseudocode, and there's one extra detail that's not in here that we'll talk about in the code. Let's jump into it. Alright, here we are in the code. I've commented it pretty well so you can see what's what. I only have one library, the IOStream, and then I'm using the specific namespaces, so it's simple. And then we have helper functions and our main algorithm function, but let's start with the main driver function. So here I'm initializing a variable to hold the result of our algorithm, and then we have our actual arrays that we're going to be working with. They can be different sizes, like I mentioned, but they have to be in sorted order, and we're just hard coding the values into here because it'd be tricky to let the user input values because arrays are not dynamic. And then we're just getting these sizes using this method I found on the internet. There's a predefined function size of, but you have to do this funky thing where you divide by the size of the index 0. So we do that for both, get the sizes, and then what we're doing here in this third part is checking which array is smaller and passing that as the first array argument. As you can see up here, we want to make sure that A is specified as the smaller one, so whichever smaller comes first. And that's just what we're doing down here. So let's move on to the helper functions. Alright, so we have two helper functions. We have a min and a max, and those are doing what you would think they would be doing. They're returning the min and the max values between two integers. We do have to do something special though here. We have to make sure that none of the parameters are null, the arguments are null. If so, then we just return the one that's not null. Alright, so let's get into the meat and bones of this algorithm. We're passing in the 6 parameters, and then we have 6 variables that we're going to be doing some arithmetic with. So the first step is to find the mids. We discussed this in our example when we were looking at the pseudo. We do the start plus stop divided by 2 for the mid, and the start and stop are 2 of our parameters. And then we're doing mid B dependent on mid A. We're doing the sizes of the arrays plus 1 divided by 2 minus whatever the mid A turned out to be. And those will show us where our splits are. And then here in our second step, we're setting the AL and the AR, BL, and BR. Those are simply these values that we talked about. What's to the left of the splits and then what's to the right of the splits. And one special thing that we have to pay attention to is we're checking whether the index number is in bounds of what our arrays actually hold. Like for instance, if we go to the array index -1, there's nothing there because you can't have a -1 index, so we set that to null specifically. If you don't have this condition and try to set it to if you just try to see what's in there, knowing that there's nothing there, it's not going to be null, it's going to be something funky. Alright, moving on. These are the basically same methods, just different conditions. So we have a condition where, let's go back to this whiteboard. So we can have, first off, we're comparing this one to this one and this one to this one. So if one of let's say this is null here, come on, there we go. Let's say that's null, then we don't even have to compare this one to this one. We just omit that condition, that comparison, and we just look at these two. Alright, so we can have 3 conditions. We can have nothing being null, like this, something like that. Or we can have one thing being null. Let's say this comparison has a null, or we can have the other comparison having a null, like this. Alright, so that's where the 3 methods come from. We will never have a situation where there's 2 nulls in different comparisons. That won't happen. That's where we get the 3 methods. So they're all pretty much the same, just a little different with the conditions we pass in. So first off, we're checking if nothing's null. That's what this condition is. And then we're checking if all the left values are less than or equal to all the right. And if they are, then we check if the total amount of indices is even or odd. If it's even, then we pass back the max plus min of right divided by 2. And one thing to specify, every time you divide by 2 for the even method, you have to divide by 2.0 so you get a float. Alright, and we have our odd condition here too if we have an odd number of indices total. And if this didn't check out, if all the lefts weren't less than or equal to all the rights, then we have to recursively call. There are two cases though. There's a case when we need to move the split forward or backwards. So if the AL, let me show you, if this one is not less than or equal to this one, then we want to move, we want to move this split backwards to the left and the B split forwards. On the other hand, if the B left is not less than the A right, then we want to move this split forwards and the B split backwards. Alright, that's what these conditions down here are doing. So this is a move backwards on the A condition, and then the else is move forwards. Alright, and then one detail that I omitted from the pseudocode is if the middle A, our new condition that we're passing in here, or rather, if our mid A plus 1 is greater than the stop, we need to return the mid A minus 1, that's no different, but we add 1 to the stop. I did some arithmetic on my own, working through several examples, and it just turned out to have this, the algorithm needs this condition to work. Alright, so then we do the same thing for the moving forwards. We check if the mid A plus 1 is greater than the stop. Then we have to add 1 to the stop so that the start condition, let me show you. We're doing this so the start condition is never greater than the stop. It can be equal, but it can never be greater. Alright, so that's if nothing was null. And then we have the same thing happening here. You can see we're checking if the left values are greater than the right, then checking if it's even, odd, and if this didn't check out, then we're recursively calling. So it's the same thing, just with a different case. The case is if AL is, so the A array left of the split is equal to null, or the A or the B right is equal to null. And if that's the case, then we do all this. And then our last case is if the B left is null and the A right is null. And we talked about this. We're comparing diagonals. That's where those cases come from. All right, so let's go ahead and run this program. All right, here we are where the executable is located. When we run this, it's just gonna print out the median, so there's a lot less output than there is functionality going on. So it gives us a median of 12, and if we look at what our arrays were, let's get rid of that. We're looking at the arrays, and I did work this out, and it comes out to 12. So it does work. We can change these up and run it again, and it give us a different value. You're just gonna have to trust me on that. Alright, so that's gonna wrap up the video. This was a longer video. The problem was a lot harder. Trust me on that. You should definitely try this algorithm on your own and reference the source code that will be on a Git repository. Thanks for watching. Catch you later.